So recently I saw a guy who did a YouTube video, Mr. Pete, he's called, from Chicago, and he asked for pictures of messy benches, and I missed out on that one. But anyway, there's my messy electronic bench as it sits with remnants of a half a dozen projects on it. And so today, so I notice a lot of YouTubers are doing these what am I doing while I'm staying at home videos. And so I guess I'm just doing kind of a little miscellaneous video here today of stuff I've done as an electronic hobbyist. So I'm 80 plus years old, and I always used to say that when I was 2 years old I had a really short attention span, and now that I'm 80 plus I'm getting that way again. So that's my excuse for a messy bench with a bunch of half-done projects. But I have done a lot of electronic projects in the last half a dozen years, kind of since I discovered Arduino and wood gas and induction heating and stuff. And so I'm just going to do a, I don't know how quick, an overview of some of those projects that I have done for a purpose, not just to make blinking lights flash and noises sound. So here we go. I'm going to try to do this in sort of chronological order, but it won't be perfect. So this is a data logger that I built starting in around 2009 or 2010. Uses an Arduino Mega 2560, and it has I think 8 pressure sensors and 2 or 3 temperature sensors, and it's got stuff in it for oxygen sensor code, throttle position sensor for a generator. It's got some what I called at the time traffic light circuits here that let me just see from red or green or blue or something what color from across the room how things are proceeding with a good, bad, and in different pressures, temperatures, that sort of thing. So that's a pretty involved thing. I think there's 1,000 lines of code for that one, but was a fun project. And if I ever get back to wood gas, I can just hook it right up again and go. Then as a result of the wood gas stuff, I got into creating a engine control unit for generators that would be run from wood gas. And here we have another Arduino project, this one using one of those Robo Red Arduino Uno lookalikes. And there's a lot of code in that one too. There's a motor that runs this rotor to pretend it's an engine crankshaft going. And then over here, there's just a simple little project that controls the speed of the motor and so on. And the whole idea is to be able to fire coil-on-plug coil packs at the right time, and to give me a lot of control of spark advance timing and that sort of thing. One of the things that I had to do along the line with the engine control unit was come up with a device to test the saturation time for charging ignition coils. And so this is a little dedicated coil saturation tester, again with an Arduino inside someplace. There it is down in there. And it's just got one function. The pots allow me to set the RPMs. I forget what one of them does, but then the other one lets me turn the coil saturation up and down as I watch for saturation on the oscilloscope, so I know what's the minimum charge time for any coil that I can use to get full current, and that therefore minimizes heating of the coil, especially at high speeds. Somewhere along the line here, locally here in west central Wisconsin, we developed a little Arduino meeting group that meets once a month, and for a while we had a kind of a this month's challenge program going on, and this was one of the challenges. It was simple, but it was basically to use a waterproof 18B20 temperature sensor and be able to control the temperature of whatever it was sensing. And so the project was to build an Arduino Uno into a box like this, and that's the result that came out of that building. And it works fine, and all I did for the demonstration was to tape the 18B20, wherever it went here, anyway, to tape the end of the sensor onto the light bulb, and so you could set the temperature inside the box here for whatever you wanted it to be for the relay in there to go on and off. And the light bulb would come on, heat up the 18B20 sensor, and when it heated up enough it would go off. And I had it sitting there at a meeting one night, and it drove one of the guys nuts going on and off. So anyway, that's that little story. So then we had one of the guys is quite a woodworker. This little segment will be about current transformers. And the idea is that we wanted to use some method of knowing whether an electrical item was turned on or not. And so I discovered these little current transformers. Here's another one that were cheap, $2-3 a piece. And I built this little circuit here which takes the output from the current transformer and turns that into a DC voltage that is proportional to the current, and then there's a Zener diode and an LED on there, so it limits the output to 5 volts. And so you can take then the output of this little board and feed that right into an Arduino input, and then use that signal to let you know that you've turned on something like the planer or the, I don't know, sander or whatever. I think this particular version with the calculations that are in there will trigger an Arduino and light the LED with anything over about 150 watts. So this guy wanted to have knowledge of turning on any one of 5, 6, 7 machines in his shop, and that would turn on the dust collector, and at the same time it would know which machine got turned on, so it could turn the various gate valves on and off at the right instant. And he wanted something that was kind of neater than this thing hanging off of the cord. So I went out and bought one of these things called I think it's called a smart plug. And this is the shell of what was once a smart plug. And the idea of this thing was that this worked with a radio signal, so that you could just push a button on, I guess, on your cell phone or something, and then it would power up this plug. So I took it all apart and managed to sandwich the current transformer and my little circuit board in there, so that now, instead of being a radio control signal to the plug, you just plug this into the wall, and anything that you plug into it through these wires will supply a 5-volt signal to an Arduino. And then, as we were playing around with that, one of the guys found this site called EMON or something like that, which stands for Electricity Monitor, and they've got quite a few circuits in there to mess around with sensing currents and voltages and what have you. Some of it's pretty complex. So I had one requirement to just over kind of a long term sense the current from some AC device, 120 volt AC device. And so I rigged up this little guy to accumulate and then read out the amount of current that was being drawn by whatever device that I managed to hook the current transformer around. And in the very complex version, they had circuits that would know whether the voltage was 120 or 240, calculate the wattage and all that stuff. I didn't want to go to all that trouble. I just needed it for one particular thing. But I did think that I might be checking 240 volt currents at some time. So all I did was to simplify it as much as possible, put an LCD in there so I could read out current and maybe some other general thing, plus calculate wattage. And all I did was to put a toggle switch there so that if I was running on 120, I'd set the switch to 120 and the math would multiply the current times 120 to give me watts. And then 240, it would multiply by 240 to give me watts. So just another little project. And for that one, it's in a little box. And I try to keep a schematic diagram with whatever it is so that if I ever want to go back to it, I might have a chance of figuring out what's in the box sometime. And you can see that I have some schematics and information around for other things. So from an Arduino and Arduino signal standpoint, right now my major disappointment is this Circuit Playground Express. It's a very capable device. I forgot it's a SAMD something or another processor in it that runs at 16 megabytes or 32 or 64. Anyway, it runs really fast, and it's got 7 or 8 or 9 built-in sensors on it. And all I wanted to do was to just write a program that would exercise as many of those sensors as possible. And I have a YouTube video on about that. And by the way, my YouTube channel is frenchcreekvalley.frenchcreekvalley. Anyhow, so I did that, and it worked. And I could make the OLEDs around the edge go back and forth. I could get it to play music. And then on the serial monitor, I could get it to read 3-axis acceleration, ambient temperature, sound level, light level, and then also output music on its little speaker. And did I say sound level? Anyway, all that stuff. So after I got that done, I thought, you know, what I really need to do is to get one of these little tiny 0.9 inch, I guess they call them, displays, so that that stuff that's going to the serial monitor all goes to the little display. Unfortunately, as soon as I got this little display and started playing with it, I could either get the display to work or some of the sensors wouldn't work. I mean, if the display worked, 2 or 3 of the sensors wouldn't work, vice versa, what have you. I spent time with Adafruit. They finally gave up on me. And when they discovered that I had bought this from China, they said, oh, well, we don't support that. It's probably the OLED. Well, it's not, because that works on everything else just the way it should. There's some kind of a conflict here. What I didn't realize when I bought this is that its SPI interface, it can only be used internally. And to make things even worse, the demo programs that they've written for this in the Arduino IDE, which are very few and far between, all use libraries that are just too fancy for me, and I can't figure out what the code used to actually perform the functions is in most cases. So if I don't use their library, I can't get the heck out of these problems. So they told me at Adafruit that I needed to buy this Gizmo, which bolts on to the back side of the Circuit Playground Express. So I ordered one, and it was like a month or 2 because of COVID-19. They were shut down. So finally it showed up the other day. So then I started looking at how to implement it, realizing I'd already soldered to these alligator pins on the Circuit Playground Express. And I didn't want to unsolder them, especially if it wasn't going to work. I looked in, you had to load a whole bunch of libraries, and I'm quite sure they're this weird kind of library where everything is really high-tech and hidden from the user to, you know, take out a function and stick it down in the loop of the Arduino IDE. It seems to me that Adafruit is now losing focus on the Arduino IDE anyway and going for MakeCode and CircuitPython, which is sad for me. It's not what I wanted to do. Okay, this is back to the Arduino area and mixing it up with wood gas. Here I've got a bunch of gasifier stuff and a bunch of generator stuff. And although I haven't done much with it real lately, what I had been doing mostly was working on adding an engine control unit to this 6.5 kilowatt Onan generator. So amongst other things, I have switched it over to a coil near plug 2-terminal wasted spark coil for ignition, and just a mess of test setup over here for supplying different things with batteries while I'm working on this whole breadboard. This Arduino setup right here contains the best version of the test bed that I showed earlier. And then over here I have another Arduino, just because I haven't integrated it yet, that looks at throttle position sensing. And the primary thing that this thing is looking at right now on the LCD is timing. And so I can adjust the timing from about 20 degrees past top dead center, which is advanced, to 45 degrees before top dead center, which is really retarded, primarily because wood gas, which is wood chips that we burn in these reactor kind of a things over here. This is a wood gas reactor, and these two guys are charcoal reactors that create burnable gas for engines. Anyway, the idea there is that I can make that timing adjustment as needed when I'm on wood gas. And then, I guess here you can see the oxygen sensor that I talked about earlier, so that I can tell the efficiency of the burning. And then the whole thing is connected to the engine by this degree wheel right here, and a Hall effect sensor setup that has 2 magnets in it, and 3 of the 4 magnets that are embedded in the degree wheel face up and one faces down, so I can tell every 90 degrees where we are, and I can tell when we're top dead center with one of the 4 magnets that's facing the other way. So now let's move across messy shop some more and switch gears from Arduino to induction heating. This setup here is based on a 1000 watt zero voltage switching induction heater circuit board, which uses 2 RFP260N MOSFETs to switch an oscillator, and there are half a dozen 0.33 microfarad capacitors in there to create a tank circuit between the capacitors under there and this work coil, and runs around 100 kilocycles or 100 kilohertz rate to heat up things, primarily ferrous things. So for this setup, I've added water cooling, I've added a fan, and then even moved to a larger fan to cool the PC board. I have a current measuring system here. I have a frequency meter, because frequency is often very important as you figure out what to do right. A water cooling radiator, a mess of wires and stuff. I have some other measuring equipment here to measure air temperature and water temperature. And then I have another more or less captive temperature meter to measure the temperature of whatever is in the work coil at the time by sticking my probe down here and into the work. Oh, and I guess I just have a little meter hiding down here someplace to make sure that my 12-volt supply for the pump and the fan is up to snuff. So that's a 1000 watt unit. And did I say that this is the cooling radiator? And it works very well for keeping things in control. So that's a 1000 watt ZVS, zero voltage switching induction heater. Now we move on to a 2,500 watt ZVS induction heater system. And there are a lot of parallels between the two, except that things are 2.5 times bigger. So this model comes with a bigger work coil. I've made dozens of coils. That container there has probably got 10 or 15 different coils in it. I won't go into them now for different purposes. This one uses 3 pairs of MOSFETs in parallel, 1, 2, 3 pairs in parallel to be able to handle more wattage. For this one I have a vertical radiator, and I have a small cooling fan, which is pretty effective for most things. And then I have an option for a much larger cooling fan if I need it for heavy duty operation. So this one also has a frequency meter, has a water temperature meter, and air temperature meter. Same system of water pump, much larger fans, and this power supply is a server power supply. They call it a hot swapping power supply, and it is really a great 48 volt power supply. They both run on 48 volts, by the way, but this one can put out up to 2,900 watts, and I've pushed it that far from time to time. Just a small point, but again, I water cool these things, and I have this expansion chamber, which is just a clear pop bottle that I cut off the top of and epoxied on here because the water expands quite a bit in there as it heats up, and it also allows me to make sure I have enough water in there. This model, rather than a pull type on-off switch, uses a certain kind of a circuit breaker, and I don't know everything I need to know, but that came with this power supply over here, and so far it's worked just fine as an on-off switch. I don't intend to rely on it as an actual circuit breaker. Again, I have an ammeter there and a frequency counter, and this is just a timer to make it easy to time events. Well, this power supply needs 240 volts in order to put out the full 2,900 watts. And so, although the power supply itself only uses only needs 3 wires because it's not using any 120, you can have 2 hots and a protective ground, and that's just fine. Since I wanted to be able to plug it in one place and power both that and the 120 volt wall warts and the fans, I decided to add a panel here that simply takes in the 240 from the main power cord and then splits it and gives me that same 3-wire connection here for the power supply, plus a couple of plugs that run down to that power strip down there to do all the 120 volt stuff. Well, I hear that the furnace just came on, and so I don't want to compete with that too much, so I'll kind of end that for today with another view of my messy bench. And I'm thinking about all the projects that I didn't cover today. I had a fascination with 18650 cells for a while, and I've got a whole bunch of projects over there on the shelf that are done, retired, and still in progress with the components and stuff to make all that stuff go. So again, messy bench, induction heaters, Arduino ECU and wood gas, more induction heaters, and a bunch of various Arduino projects. And that's enough for today. Thank you for watching.